this can end being something completely different. So, Pocho, when
Almost
can we
ready.
start? Okay.
Almost ready.
Okay. Well.
Boris has a mate. You know, he's drinking mate. Cool.
Oh, cool. Yeah.
Yeah, you know, that huge bag of sherba that Andres gave me some time ago. I just finished it yesterday, and this one is what you can get here in Canada, and it's some kind of joke. It's some kind of bubbly thing. I made it, and there are little bubbles. Like I was holding it like this, and I didn't understand what it is on my hand here because there are little bubbles that go outside and kind of land on your hand, and like the one that I got in Argentina, it didn't, it didn't do this,
Oh,
and this
Ken.
one is kind of champagne, like it has this behavior of a champagne, and I think it's not supposed to be doing this.
Yeah, but Boris, don't blame the Sherba, please. It's all your fault. Don't blame the Sherba.
Okay.
Freezing on a iPhone.
Take a look at Ken's phone. It's running.
Freezing on a iPhone.
Hey, it's
That's
running
nice.
grease. Yeah.
Okay, we are recording now and live streaming. I don't want to
Okay.
interrupt, so if you want,
Okay.
you may start. I just want to thank everybody here, to thank Fast for being the one that organizes all these talks, and to all the people that collaborating on setting up everything. So I think Juan, you can start.
Okay. Hello. Thanks everyone who helped this happen. And let's get started. I will share my screen. No, Pocho, I need you to enable my screen sharing again. Yeah.
Okay, I'm going to help with that. So you should be able to do it now.
Cool. Okay, let's see. Well, can you see my screen?
Yes.
Can you see
Yep,
my
we can see
screen
it.
now?
Yes.
It should show a slide. Okay, cool. Well, this talk is about vector graphics in Quiz Smalltalk. So I want to start with a short, hopefully very short, historical perspective on what this is all about. Okay, so this is a Xerox star. Since Xerox Spark work started on the Xerox Alto and maybe a bit earlier, people have been building software to do graphics on computers. The Xerox Alto and the Xerox Star, that was a commercial product, were interesting because they were the first system where you hoped to get a printed page with exactly the same content as on the screen. What you see is what you get. This was called, okay? The Alto was specifically designed to be able to do this kind of things. But shortly, these two technologies, the printed page and the computer screen, started to diverge. Computer displays got better at showing interactive stuff that changes quickly, so high performance is important. And over time, they started to get very good gray and lighter color depth, using many bits to specify the colors in each pixel, okay? But they stayed low resolution for many years, and the user interfaces that started to be designed for them forgot what one of the objectives of the original design in the Alto and the Star that was to make the stuff that could be shown on the display independent of whatever hardware you had. And the user interfaces started to be designed specifically for a computer platform and for a pixel resolution, with the stuff that is shown made at specific pixel sizes. On the other hand, printers got better at pixel resolution, okay? They started with roughly the same resolution, but laser printers and most printers started to be able to do very high quality and very high resolution output. And that forced it making everything resolution independent. Okay, nobody ever had any trouble with stuff looking different on a 300 DPI printer or a 1200 DPI printer. So portability was a reality almost from the start with systems such as TeX, PostScript, and PDF. But gray and color depth sticked to 1 bit per pixel, so the smaller dot that could be shown printed by a printer was either on or off. This is different from a computer display, and they used halftoning for emulating shades, gray and color shades. And they also slower or have been slower for a long time, okay? But in recent years, computers got way faster and displays got much better, okay? Even though current software doesn't know what to do with that high resolution. And that's why we have lots of problems scaling regular user interfaces to different displays. People using any major PC platform like Linux, Mac, or Windows have had a problem when using high resolution displays. So, but we can do better, okay? We can do better than that. The approach, the obvious approach, is to write a new user interface framework, okay, that is based on vector graphics and not on pixels. This is not a new idea. Previous systems such as News and Displays PostScript were attempted, but the computers at that time in the late 80s were not fast enough to run them, and so the experience wasn't good at all. But now it can be done. So what is needed to make this real? I needed a new Smalltalk system, a Smalltalk system that could evolve, okay, that is not tied to whatever was built with it at the time. And I'm talking about Squeak. I needed something like Squeak, but that could evolve. The result is Quiz Smalltalk. And a new redesign in the user interface framework that I called Morphic 3. And this needed a better graphics engine. So, Quiz is an open source Smalltalk system forked from Squeak many years ago. And the idea is to make it simple enough so it can evolve and not become legacy software, okay? It runs on the same Open Smalltalk virtual machine as the rest of the Squeak family. And it is a very practical and useful system used for many applications, and as you see on the slide, and others too, okay? I also did a new redesign of Morphic, where Morphic is a user interface framework designed by Sean Maloney for Self and later Squeak. And this is a new, a third iteration on that design, where all coordinates are floating point and not integer. So they don't specify pixels, but real positions on a real plane. Also, all coordinates are relative to a morph local coordinate system and not global, so they are not specifying pixel position. And this coordinate system can be scaled and rotated, and that gives us resolution independence. Okay, so we completely forget about pixels. And we use vector graphics primitives and art, and try to avoid pixel-oriented primitives and art. But we can use them if needed, okay? So, when I started this project and I started using the old Balloon vector graphics engine in Squeak, I didn't like the results, okay? Then I tried Cairo, the very popular vector graphics engine, and I didn't like the results either. And I had specialized in image and signal processing at the university, so I knew the theory that should be applied. Okay, so we should stop using computer graphics algorithms and start using signal processing theory. The result from the signal processing theory point of view is much greater real flexibility in design and choosing an anti-aliasing filter. And that allows us to really avoid aliasing and pixelation. Okay, I developed a new set of algorithms for working with, for applying this well-known signal processing theory. And the last bullet in that slide is a short paper I published about it. Okay. The next things will be a demo. The demo is based on material I wrote for a chapter of the quiz book. The quiz book is new work, a new project led by Hilaire Fernandez with help from Kendike and I. We wrote together this book, and chapter 7 is a description of Morphic in the line of what I want to show today. So I will exit this presentation now. I will remove this, and this is the current PDF, the current draft PDF of the quiz book. Okay, it starts with a description of what Smalltalk is all about, and then a practical explanation for newcomers to Smalltalk. I'm very proud of what we have done here. So I suggest everybody take a look at it. I hope you will enjoy it. Okay. So let's jump to Morphic. Well, this is chapter 7 of the book on which I am basing the demo that I will start right now. What is Morphic all about? Okay, Morphic, the idea of Morphic is to take the fundamental idea of Smalltalk, that everything is an object, to the user interface. So in a Morphic user interface, everything is a morph. Any object that can appear on a display and interact with. Okay, so it's not based on the idea of solving a problem like most user interface toolkits. The idea is to be flexible enough so you can have any kind of graphical interactive objects on your display. Can you see my quiz desktop?
Yep.
Yes.
Yes.
Okay, cool. So it's been only 20 minutes so far. We are okay. Okay, so What is the simplest graphical object we might try to build? The obvious answer is a straight line, okay? So I have here a few files with some of the code from the examples from the book. So I will show them to you using the regular Smalltalk tools in Quiz, okay? So the simplest morph we can try to build is a line, and a straight line doesn't need much code, okay? We define a class, and then we teach it how to draw itself, okay? I will file in this code. Okay. So this class has only one method.
I'm
Yes.
not seeing any change on the screen. I don't know if the rest is seeing
Same
some
problem
change.
here.
Me neither.
Me neither.
Nobody can see a green browser that I'm moving around.
No.
No, the
No.
screen is not updating.
Okay, I will stop sharing and start sharing again, and hopefully it will fix. Okay, I'm not sharing now, and now I will share again. Can you see my quiz display?
Not yet.
No.
No, not yet.
Oh gosh,
Just a-
what?
I cannot.
Just a black screen that says that you had started the screen sharing, but yeah, it's not showing anything.
Oh gosh.
Do you have two screens there? Might be
Yes,
the
Yeah.
but
sometimes.
Are you sharing the desktop, or are you sharing a special window?
I'm
particular
just, I will start sharing a desktop again. Can you see anything?
No.
The black screen again.
Well, and try sharing just the window.
Yeah, that's right. Just share the quiz window.
Okay, let's see how to do that. I had practiced this. Okay, maybe this works. Can you see?
No.
Give it time, because it has to. It works with kind of VNC style compression, so it takes a while to download the keyframe.
Okay, I hope you can see anything at all now.
If not,
Otherwise-
I will suggest
No,
the
not yet.
unpopular option of restarting Zoom.
Yeah, I would try
Okay.
one thing first. Why don't you just quiz?
Okay, I will quit quiz screen. Okay, so all I have now on my display is a file explorer. And if I try to share that, can you see anything at all now?
No, same thing.
No, same thing.
Okay, I guess I will exit the meeting and enter again. I don't know what else to do. Most likely it is this Keynote application that has a full screen mode for presentations that seems to do crazy stuff. I already quitted it, but okay. Wait for a second, I will exit.
Okay.
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 Meanwhile, talk amongst yourselves. How are people doing?
Oh, we're doing fine. I think the problem is that Zoom didn't like the one's vectographic. What?
Yeah, the future is animatronic faces, right?
He's here again. He's trying to connect.
Wasn't that something which Squeak had for a long time, like this animatronic animation face with the synthesizers in them? think.
Well, the thing I'm interested in is how you go from webcam video to the parameters. I've seen some people who one guy on LinkedIn who's doing eye tracking with machine learning. I hate that kind of.
There we are.
A non-solution anyway.
Yeah,
you can
see that.
Okay, great. Thanks.
Yes.
Great.
Okay, well. Oof.
Looks great.
Can you still see it after resize?
Yes.
Okay. Oh, cool. Well. Okay. So let's get started. I will do a short preparatory step. Okay, that's all. Well, so what I was trying to do is to build the simplest possible graphics object in the world that is a straight line. Okay, so I have a few files here with code.
Yeah, it looks like we're not seeing anything moving. We're probably not seeing it again.
Can you see a blue window and a rather pink window behind in my Quiz desktop?
No.
No. So
we only hear your clicks.
Yeah. So what I would suggest is resize the quiz window to the minimum size that's going to allow you to demonstrate, and then just share the window.
Can you see it now?
No, it's black again. We're back to where we were.
Maybe it's a traffic problem. Maybe you should switch off the camera.
Yeah, stop video and.
I just did stop video. Can you see something now?
No,
try resharing the window.
Resharing, please.
And now? Can you see something?
No, it's the same.
Oh, this is extremely frustrating.
Yes. But don't worry. You know, Ron and I, yes.
Yes,
now it is.
There you go.
Now you can see it?
Yes.
You're showing us the entire desktop rather than just the window. You can't share the window?
But
we can see the window itself.
We can see it now.
Yeah.
If you can see it, I will touch nothing else.
Yeah.
Can you see me moving the transcript window around?
Yes, we can.
Okay, well, that's enough.
I don't know what you did, but it was magic.
I picked the optimize for clip for video clip option. That should not be needed, but whatever. If it works, it's enough for me. Okay, so these are the code files I will have around for this. I just filled in this class, line example morph. It's a subclass of movable morph, and it has a single method. Can you see the code for the method now?
Mm-hmm. Yes.
Okay. In Morphic, morphs have a drawn method where they draw themselves, and the argument is a canvas. A canvas is an object provided by the framework that has drawing primitives. Okay. So our straight line tells the canvas we want to draw something with a pen with a width of 20 something in color green. And then what we are doing, a block that says move to this position and draw a line. Okay, that's all. So it will draw a line between these points with some width and some color. Okay, this is our line. As I told you before, each morph defines its own coordinate system. So let's see what is the coordinate system for this morph here. It is this one. Okay, can you see the coordinate system axis?
Yes.
Yes.
Okay. In Quiz, the halo also shows the coordinate system, and it's tailored for whatever the morph needs. Okay, and as I told you before, a coordinate system can be scaled, okay, or rotated. Okay, so this is these are the fundamental ideas of the Morphic 3 implementation of Morphic in Quiz. Okay, some things that we can do. This is not specific to us, but the other Morphic implementations can do this. We can grab our morph here and open a menu and say we want to make it submorph of the other line, and then both of them go together. Something that is interesting here that you may not notice is that you can grab the morph with the hand, and you don't grab it if you click outside the line, but we didn't need to implement a method to check for geometry and validate the point to say whether it belongs to the morph or not. That is a major source of complication in the other implementations of Morphic. Is not needed here. That is handled automatically by the framework. Okay. So let's now do a slightly more interesting morph. This is our triangle example. Let me file in just this methods. We only have an initialize that picks 2 colors and a couple of draw instructions, nothing else. If we create an instance, this is an instance, this is another instance, this is another instance. They have different colors, transparency, etc. We can, as before, embed one inside the other, and then grab them as a unit, and as usual rotate and scale. Okay, but we can do more stuff than this.
That's beautiful.
It's fantastic.
Thank you. Okay, thank you very much. Yes, I worked a lot on correctly applying signal processing theory to the rasterization of the vector graphics. So yes, it looks better than most. Okay, we'll do something else. We'll add some, there is some noise over there occasionally. Okay, I don't hear it anymore. Okay, we'll tell our morph that it wants to receive steps. Steps are signals, periodical signals from the framework that trigger some action. So the morph can do stuff without needing we to tell it via messages. Okay, it's periodic activity. So if we fill in all this code, we say that we want steps that we want to be stepped every 100 milliseconds, 10 times per second. And this is what we are going to do on each step. Okay, so
if you create the things in the first place and join them together without the step method, and then you turn on the step method, does that work or does that break? Is that something that you can turn on dynamically, or is that something that has to be on from the moment that morphs are created?
It should work. I haven't tried it for this demo, but if I do self-stop stepping, it should just stop stepping, okay? Yeah. And then I can, for example, create another one. It should be possible.
Next time you give this demo, join the 3 up and then file in the stepping methods. And if you can get the thing that you've already connected to then suddenly start rotating, you're going to be, that would be incredibly fantastic to see.
Okay, we can, interesting. We can try it and see if it works, okay? No problem, no problem. So we'll remove the stepping stuff. Okay, and then I create them one by one so they have different colors, because if I just clone one of them, it will have the same color, obviously. Okay, so embed into the previous one and embed this into the previous one. So now they go together. Okay, and the stuff works as usual. And let's see what happens if we add the stepping code right now. These are the new methods: one step, step, and step times. Okay, so the code loads and nothing happens. So let's see if we can make it start. Yeah, there it is. It works. Can you see it?
Beautiful.
Okay.
Yeah, it's moving.
Yes, I needed to do start stepping because the system is not sending the method one step all the time. It sends when a morph is added to the world. Okay, but this step method is not really interesting, so make it do something else. Yeah, something like that, for example. And we see that only one of them is stepping, right? Only the outmost one is stepping. So let's do triangle.
We lost him?
Yes.
Oh, man.
No.
Thank you, Zoom.
I think he's having a problem. Let me see if I can reach him.
Let's send a message. Juan, start stepping.
This is terrible.
I used to work for Apple Computer, and when you were giving a demo, if it crashed, then you had to do push-ups on stage.
That's funny.
So was Apple fit, or was Apple kind of unfit?
I'm not going to go there.
He's trying to connect again. PC unresponsive. That's what he got. What's that? I think he's using a Mac. Why a PC?
Busy and unresponsive. That means you're being productive.
So in the meantime, somebody say something. Leandro, you want to say something?
I can't. My mic is mute.
It's not. We heard you perfectly.
That's funny.
You're the president of FAST. Come on, say something.
Say it fast. Yeah.
You wanted to announce the Zoom implementation in Smalltalk.
No, I think that
We're working on it.
no, maybe Juan didn't prepare the presentation and he just ran away.
No, he's not. It's not a good day for him today. It's not a good day.
What's a word that means even more than Zoom? If you were to Zoom. There you go, Ron. We should call us Zoom, right?
Zoomier.
Yeah. Zoomier.
Zoomier.
But he added Muzak. That's great.
Yes, he's restarting the PC. The PC stopped working. I don't know.
Wow.
Yeah, weird. Maybe the heat. Zoom is. And I think the problem is that VM, that Smalltalk is using.
Yeah.
That Quiz uses. I don't know who wrote it, but.
I think it's cycles.
Yeah, it's using too much CPU and
memory too.
Yeah, that's terrible. Yeah, even more that the GraalVM. Fabio can say that. Okay, let's hope he got the music. That was nice.
Yeah, where'd the music go?
I don't know.
Oh, the problem with the music is that then YouTube will block the video.
Oh, yeah, I hadn't thought of that. That's interesting.
Yeah, one thing we could do is everybody turn off our video. Let's see whether that makes anything better. If we keep the sound open, the sound is a tiny amount of data, but the video is huge amounts of data.
There he's
back.
He's coming back. Yeah, he's coming back.
Meanwhile, I want to remind you that any of you can participate here in this talk, so you're invited to send to the address of the place where we are organizing this. You can send a talk so that we can schedule you a
Ocho,
slot.
please let me share again screen.
Yeah, I'm looking for your name in the list, but I can't find
Well,
it.
I know it's a pain, but let me recommend that you try and share the window only and with the same
Okay,
set.
yeah, sure.
I'm sorry to be so controlling, but it's worked well when we've been doing it over recent weeks.
Juan, maybe it was a heat problem, problem.
I don't understand what you say, and I have no clue on what you
No, sí, por ahí fue un problema de temperatura de la computadora. Con Zoom y todo prendido. ¿Tenés prendido el aire acondicionado, boludo?
Sí, tengo prendido el aire acondicionado.
Está bien.
La próxima vez. Next time I will use an old-fashioned Linux desktop PC and not this modern MacBook that failed me today. Okay. Let's see if I can share.
Oh, if you get a new M1, it should
yes,
no heat
beautiful.
Okay. Well, let's start all over again.
This is very, very visible as is. So, oh, gorgeous.
Wow.
That's a beautiful font. I want that in my script now. I want to write code in that thing. I will be more elegant.
I will say that that's a beautiful anti-aliasing.
Yes, thank you. Yeah, that font is included in the quiz repo by default. I picked a small set of free fonts that could be included without trouble, and I included it. Okay, so let's start where we were. Okay, so I don't have the stepping code, okay? Again, I will create a couple of triangles over here. And let's see if we can make it work this time. Okay, so here we have them, and now I will file in the rest of the code.
Note to self further on that as you go through the menu of morphs to embed in, so the menu selection should mirror a highlighting of the morph itself. That would be super cool.
The morph,
So as you go through the list of morphs that you say embed into, and it gives you all of the other morphs, right? It'd be great is if you skip through.
Oh, yeah, I get to get visual feedback on which morph you are talking about, right?
Yeah.
Yeah, I hope I will remember to add it afterwards. Yeah, it can be done, of course. Well, here it is.
Yes.
They are starting to work. Okay, but what I was trying to do is to do something a bit more interesting in the step method.
Don't do it. The last time you did it.
Well, but this is what we are here for, okay?
That's beautiful.
Oh, fantastic. Beautiful, man.
Okay, and now, yeah. Okay. So,
bravo.
There is a reason why this may have a hit on the computer, and it is that I haven't yet built primitive code for the rasterization. So every pixel is being drawn in Smalltalk code right now. It's not using anything, any C or assembly or DLL or FFI or anything at all. Yeah.
So, Juan, one thing is that we are looking at this from Zoom, so the quality is not the same as you get in your display.
Yeah, I guess.
So you have to tell us how beautiful
it looks great. Does that work? Okay, well, let me tell you, this is just a demo. I really encourage everybody who likes this kind of stuff to clone the Git repo and run it yourself on your machines. The quiz book is online also, and this stuff is chapter 7. So if you want to play for an hour or two with this kind of stuff, you can do it right now. I will show you a little bit of the code that does the actual rasterization. Okay, this is the code for the engine. And you remember that in the draw on we send a message setting up the general parameters for the drawing, and then vector graphics operations that are drawn using that color and stuff. So one of the operations we do is to blend. Well, I would need to explain the algorithm for this, but this is the method that actually modifies the pixels on the display. So it does all this math you can learn about, and does target form bits byte output. Okay, if I remove this, it will draw nothing, and when this gets a decent primitive, when all this code is running in native code, it will be much faster. That's what I was trying to say. But the thing that happened this year was that Hilaire joined our community, Hilaire Fernandez, the author of Dr. Geo, a wonderful project, and he started to show interest in this, and he wanted to be able to use it, and I rushed to make it usable. So the primitive code will later be written. I'm thinking on a VM plugin written in plain C for this. And it's a kind of detail we can get into later if you want. Okay, so I have yet another example to show you that I hope it works better than, or at least it works the first time we tried. And it's a clock. Okay, we have all the elements we need to build a clock. And right now I just finding the class definition and this draw on method. Okay, so if we create a clock, this is what you get. Some of you, maybe those who live in Argentina, may recognize the prestigious brand of this clock. It is a Shakir par la minorie.
Yeah.
And nobody laughs. Okay, it was invented by Lelutier for one of their shows. I thought everybody was.
I did. I was mute, but I did, Juan.
Okay, okay. Well, I also created the hands. Okay, and the hands look like this. This is a hand for the hour. This is a hand for the minute. and this is a hand for the seconds. And as you imagine, you can also do this kind of stuff with the hands, of course. So no, I want the browse. Yeah. This class is the only thing they have is a small drawdown method, okay, that draws this polygonal shape with hard-coded measures and nothing else. And we can build our clock by setting the instance variables with the hands, okay? And now I will remove this. Oh, by the way, the coordinate system stuff works on any kind of morph, right? So you can study and understand what the coordinates mean for any morph in the system. Well, our clock will want steps, and now the method that updates the clock. The method that updates the clock, all it has to do is to give each hand an appropriate rotation, okay? As a day has, as a one rotation of the clock means 12 hours, we have 30 degrees per hour, because 30 by 12 is 360. And similarly for the hands, for minutes and seconds. So I load this code, and now our clock works, okay? And as you can imagine, well, you can, of course, clone it. You can squeeze it. You need to run this on your machine and maybe get a magnifying glass to see how the anti-aliasing on this nice font looks. It looks really nice. And something else that you can do, for example, yeah, there you have the coordinate system of the second hand that rotates as the hand rotates. And essentially that's it. This is the demo I had prepared for today. I can show you a couple of additional things, but the key idea here is that building morphs that are interactive, that are dynamic, that are animated, and that have high visual quality, that they look as they should, doesn't require too much coding, okay? The drawing of the clock draws the face, that is just a circle. A circle is an ellipse with the same radius in X and Y direction, okay? Then I just draw the labels, and that's it, okay? If I don't need the labels, all the code in the clock is just the ellipse, right? All the rest of the stuff is there just to make it more interesting. So a minimal morph is something that is really small. And the hands are even simpler, as all they have is one drawing operation, okay? Something else that I wanted to show, that is, this finishes the main idea I wanted to show, that building morphs should not be complicated, okay? Morphic wasn't designed to be complicated. If it became complicated afterwards, is because it has grown without the required care for avoiding complexity. Okay, but it can be done better, and I tried to do it better. Now I want to show you a couple of things that this vector graphics engine can do. I hope the display updates properly for you to see. I wrote an SVG. SVG is a standard file format for vector graphics, and I wrote an SVG parser that turns it into Smalltalk object that represent what is inside the SVG file, and that can be drawn. Okay, so these are some examples of SVG files I downloaded from the web, and they can obviously be drawn with different scale, rotation, everything. Okay, like all the rest of the stuff. So you can run these examples on your own machine to see them free of any compression artifact by Zoom or whatever. And something else I want to show you is this. You saw those nice fonts, text renderized with nice fonts. The font we're using right now is a TrueType font, is a vector graphics font, and it can be used, yeah, we can use, everybody liked this Alex Brush font, so we can use it for all the system, of course, there's no reason not to, and we can make it bigger so we can read it easier, okay? And this is a TrueType font, and I used the Morphic3 vector graphics rasterizer to draw them. Okay, this is not using a third-party TrueType rasterizer such as FreeType or whatever. We're using only pure Smalltalk code to draw the TrueType fonts and cache them in a bitmap for this display. And I also wrote some Unicode. What is this? Sorry, I don't know what is this. Some Unicode support. And there you can see some samples rendered on not only on Latin glyphs, but also Chinese, Hindi, Hebrew, and many others I don't even remember, Greek, and others, yeah. So
sorry to interrupt you, but somebody's asking if the buttons on the Windows are not vector graphics because they look pixelated.
Yes, exactly. These are not vector graphics. These are regular bitmaps. They are the same we use at this size. At this size, they are unscaled, but to draw them at larger scale, the bitmaps are scaled so they look pixelated. My idea for but I will do this only after building the VM plugin for the rasterizer, is to replace all these bitmap icons with vector graphics icons, so they will look better at any display resolution. We are still in a transition to using this. For example, if we inspect the world, maybe I should change the font so you can read easier.
Oh, it's lovely.
Okay.
No, please don't.
Okay, cool. The world holds a canvas. It's a canvas that is used for drawing everything. But this canvas is a hybrid canvas. And a hybrid canvas well, this is the morphic canvas hierarchy, okay? The morphic canvas hierarchy, it's hard to get, there it is. Has the regular BitBleed canvas, that is what is used by default when you launch Quiz, okay? If you start Quiz, it will use the regular BitBleed canvas. That is essentially the same that is used by Squeak, although in Squeak it has a different name. I choose this more clear name telling that it is based on BitBleed. And I brought the new vector canvas that uses the new vector graphics engine. But drawing everything in pure Smalltalk is a bit too slow. And here you can see that this drawing has no performance problem. It runs essentially at the same speed as if it was in BitBleed. So what I wrote for only for provisory use, for interim use, is this hybrid canvas that is a subclass of BitBleed canvas that only that adds a new instance variable that is called vector canvas that is only used to draw boards that cannot be drawn by BitBleed canvas, okay? So the browser is now being drawn by the code inherited from BitBleed canvas. It's a regular BitBleed browser. But if I create a clock, BitBleed cannot draw the clock because it's using the new vector graphics primitives. So when I create a clock, the clock, oh yes, I changed the default font, so it tries to use it whatever it is. When this hybrid canvas needs to draw the clock that uses the new vector graphics primitives, it calls the vector engine and draws everything in Smalltalk. That's a way we can have a responsive system for using the old tools, and we only pay a high performance price for the new vector graphic stuff. When we have the vector engine plugin and everything works fast, then I will remove hybrid canvas and BitBleed canvas could become optional, and everything will be drawn purely using vector graphics, and these icons will no longer be there. So, well, this is all I had prepared, and you can ask questions or whatever, or say whatever you want to say.
Thanks.
That's beautiful.
Very good. Very good.
Thank you so much. I stopped the screen share, and maybe I can use my camera again. So.
Why did you have problem with that?
Yes, I was terrified. At some point I thought I would need to ask everybody to reschedule this for some other time where things would work. Oh.
The first impression I had, apart from the beauty and the functionality, was that it reminded me when in the late 80s, early 90s, I saw news from Sun, but this is comprehensible, and the language is so much more beautiful to program in. but it's the same kind of superb expressive power. But then they weren't. They didn't even have something as beautiful as your clock. Things were very crude, right?
Yes, I named news in one of the slides I showed at the start when I said that vector graphics for interactive systems is not a new idea. There was news and also there was display PostScript, but computers were not fast enough to do it. So yeah, the visual quality was not good, and besides they didn't have a Smalltalk and Morphic, so everything was way more complicated. So yeah, here we are taking advantage of everything we have. Modern fast computers, signal processing theory, the ideas of vector graphics that these people used, and Smalltalk, of course. And the signal processing theory is something that I keep repeating, because to me it's a shame that people working on computer graphics don't study signal processing.
Do you have a list of reading material for people interested in that?
Yes, the easiest place to start, let me paste a link, is a Wikipedia article on anti-aliasing. That already discusses the stuff. Let me look for it. You can also check you can also Google for my short article. The spatial anti-aliasing article on Wikipedia. I'm pasting the link in the chat. Is quite good. At the first picture they show, they talk about a sinc filter. A sinc filter is a signal processing theory filter that does the stuff that should be done. And that people working on computer graphics seem not to focus on that. The third point in the Wikipedia article is signal processing approach to anti-aliasing. And that's what I am doing. Yeah.
No, I have a question, but please finish.
No, that I just was going to remark that I started doing these things before the Wikipedia article was written, and I was very happy when they started to talk about the real stuff in there a few years ago.
I did the Squeak from the very start video series a while back. Have you ever seen it?
Sorry, what are you talking about?
Have you ever seen my introductory Squeak videos? Squeak from the very start?
I'm pretty sure I have, yes. But
yeah, well, I'd love to do something like that for Quiz.
Of course, be my guest. We can chat afterwards if you want, and you will have all my support and any help I can provide, of course.
Yes. Well, I have to learn how to do this stuff before I can show others how to do it. So.
Yeah, well, that's what we wrote the book for, right? So more people could get into this kind of stuff. And now I pasted the link to the article I wrote on this stuff, on the technique used by Denshin specifically. And the reason I wrote this and the reason I published it here is because it's a much better alternative to what others who are doing for anti-aliasing text. And I remember that at the time, for example, Microsoft had patterns on subpixel anti-aliasing they called ClearType. And so, for example, Linux needed to come with subpixel anti-aliasing disabled by default, and Apple never used it because Microsoft had patented it. And I came up with this idea that is better than ClearType, so I was scared that someone would patent and steal it from us. So I published it in a way that is in the previous art intellectual property database that the US patent office needs to consult before issuing a patent. So it's really free now. Nobody can patent this now.
Question at 12:09. Justin, can you unmute yourself when one is finished and ask your question?
Okay. This just one more remark on this article. If you are going to read and you are interested, it describes how to sample 2D graphics using sampling theory, and it doesn't describe the subpixel version, but the subpixel version is just taking 3 samples per pixel, one at the position of the red subpixel, another at the position of the green subpixel, and another at the position of the blue subpixel. And both are implemented in the quiz code. If you take a look, there are 2 engine classes. One is subpixel and the other is whole pixel. So all the stuff is there.
You plan to generate the C code from Smalltalk with Slang or something?
No, it's about. Let me see how many lines of code does this have. I don't even remember, but it's very small. The whole pixel, yeah, is about 380 lines of code. And so most likely I will rewrite it in C, because that will allow me to use SIMD idioms in C to generate higher performance code. Okay, there are ways to process several pixels or several subpixels in a single assembly language instruction, and there are C extensions, at least at GCC, to take advantage of that. And the Slang C code generator cannot use them right now. And the C code is not too much, and I have written a lot of C code in my life, so I will just write a little bit more. Some time ago, some years ago, I had the experience of using OpenCL for image processing of satellite images in real time for Satellogic. And I really liked the experience and I was very happy with it. And I wanted to use that for this project. I actually wrote the OpenCL version of these routines. So I haven't written them in C yet, but I wrote them in OpenCL. And they work, but they are extremely slow. And the reason
have you looked at Apple's new M1 features, or I guess they're the Big Sur features?
No, not yet. No, not yet.
The M1 features, which are not M1, they're ARM v8. You know, they provide all of the kind of small vector operations that you could imagine. They typically work on 1 to 4 element operations, and the data types are from 16-bit to 128-bit floating point. So you can have a 128-bit element with 4 elements in the vector and 1 instruction that operates on them. What I wanted
that seems to be a bit more than what Intel offers, but Intel has offered these kind of things for a long time already, and there are intrinsics in GCC to access them from C.
Right. All I wanted to say was that, you know, that the ARM stuff is a little bit nicer than the x86-64. It's a more comprehensive thing. But what I wanted to suggest is that we at least have a research project to compare the C against generating that code directly in the back end of the JIT, because that's what the sister optimizing instruction set is designed to support. So extending that instruction set to include those data types has always been the desire, and then that would be generated automatically from the Smalltalk without any.
Okay. A first step in that direction could be to use Sista as it is right now for this code and see where we get with just that first step.
Elliot, as an aside, do the 128-bit vectors include integer? So you could use that within, say, the MPFR for multiplying integers?
I'm not sure that they support 128-bit integer data type. They certainly support 64-bit integer data types. I know
right, but that's
data types are, you know, you get the ARM V8 manual, and it's only 8,000 pages. It's tiny.
oh, okay, sure. Instant download.
So they have 16, 32, 64, and 128-bit floating point, and then you know, at least 32 and 64-bit integers. I'll have a look. I can get back to you.
Yeah, because the difference between that arbitrary precision floating point and the MBFR-based floating point, or the arbitrary precision multiplication, was a factor of, I think, 16. And if you were to extend that to the built-in very large integer type on the Mac to use 64 bits, it would only be like half as slow. So if we could actually extend it to a full 128, then you would have on the Smalltalk running on the right machine something that would be actually even faster than the dedicated C libraries you can get open source.
Yeah, sure.
So you could, people that need that kind of thing would be going to Smalltalk as their easy way of doing arbitrary precision floating point.
Something that I've been meaning to comment on for some while. There were these scattered bits of discussion on the quiz mailing list about what do we do with SqueakNOS, and thing is something that we've always been emphasizing back in the OTI days when I was back there, is that what makes really interesting things is this Ouroboros symbol, right? The snake that bites its own tail. So it's like the projective line where the opposite point, the opposite infinite points in the line, they're actually at the same point. So the extremely large machines that only very few of the richest nations can afford to build one, and the extremely small machines, they actually can use the same, you know, Smalltalk-like technology. Or you know,
have you ever talked to Giselle about the Silicon Squeak project?
Well, yes, that's where I'm going to.
Ah, okay.
So the belly of the Ouroboros, right? Your normal workstation in that sense is kind of not interesting, right? Because it's extremely, I mean, this is the mainstream desktop machine, and it's extremely difficult to be relevant there when all the competition, basically all the slices of that cake are taken. I've with SqueakNOS and with putting the Open Smalltalk VM onto different quote-unquote interesting processors, I've been investigating different possibilities how to be interesting in unique ways. And one of them is what the Open Power people are doing with building this little sub $100 like build your own CPU and learn how to design CPUs kit. But the challenge there is staying on the cheap side, certainly below $100. And with PowerPC, what you cannot do is you cannot have the C language on that, because the C runtime really requires some extensions to the minimal PowerPC core that you cannot afford on a small FPGA, certainly not under, say, 50,000 gates. And then what they can do is they are putting MicroPython and that kind of stuff there. And what I've been playing with is trying to put SqueakNOS on this kind of cheaper FPGA, not the cheapest, because there are these Lattice FPGAs that cost, I don't know, $5 a pop. But you know, there's like ARCI A7 boards. And one of the problems that I've seen is that floating point, to have an FPU, is already prohibitively many gates. And if we are struggling with putting vector graphics on top of like normal FPU, what has been done a lot in the PowerPC world is that the PowerPC, because of how it was licensed from IBM and from Motorola to actual manufacturing partners, is that it has this kit for making coprocessors, and there's a lot of open source coprocessors for signal processing. There's a coprocessor for complex numbers. There's a coprocessor for filtering, and I'm wondering if you know, so some of them are kind of lower transistor budget than a full-blown FPU. So I'm wondering that if we look at what we actually need, like what subset of operations of signal processing operations we need for vector graphics, we may with a very minimal amount of work required, especially that there is, you know, I don't really know how to interface from OpenCL to this coprocessor hardware API, but I'm sure we can come up with something, is that it would be really cool to just have vector graphics on a dedicated coprocessor, just synthesized from an OpenCL definition. And that way to get rid of dependency, I'm not sure, like, Juan, do you think it is possible to kind of isolate where we really need just generic floating point? Because I was playing with, not with quizzes, but with Squeaks, this minimal reader image, right? And because it pulls everything, it tries to start up Morphic 2, and Morphic 2 wants coordinates, but it wants floating point. And because the VM, my VM port, because it doesn't synthesize FPU operations, I was kind of choking there. And it was kind of like, okay, I have to manually surgically remove that part of the image from there so it doesn't choke on no floating point support in the VM, specifically in Primitive 7, where it tries to compare for equality between two floats.
If I may answer,
yeah.
Removing floating point from Morphic 3 would be almost like killing it. Okay, you would go back 20 years in visual quality. So I think that is not a good idea. However, in Squeak, Morphic 2 should not require floating point. And if some floating point objects are leaking into BitBlit or any other primitives that are being used in Morphic 2 in Squeak, you should be able to inspect the call stack, the Smalltalk call stack, and see where you need to insert a rounded message sent to convert it into an integer. You should fix it in Squeak, and I guess those fixes should be considered improvement to Squeak.
I just want to say one thing, because it's a persistent misunderstanding that I've been seeing several times in the past 3 weeks, and that's the distinction between Sister and Scorch, the optimization system, and Sister, the bytecode set. So Sister, the bytecode set, is a bytecode set that supports Squeak, but also has a room in it for 256 assignable opcodes, of which we've currently assigned some 30 of them. Which would extend to cover a whole series of unsafe operations that cannot be used directly from Smalltalk because they don't do checks. So they're entirely non-polymorphic and they're fixed. But what we have in Squeak right now is that we can compile normal Smalltalk to the Smalltalk part of the Sister bytecode set, and that really makes no difference in how fast Smalltalk runs. In addition, if you then augment the VM with support for that unsafe bytecode set and with a baseline JIT that includes performance counters, then that system identifies hot code, and up in the image, something that's called Scorch, which is an adaptive optimizer, analyzes the Smalltalk code. So it would analyze one's pure Smalltalk, and from that would generate new versions of the methods which use this unsafe instruction set that currently Squeak does not use. And it's that unsafe instruction set that then allows you to generate the non-polymorphic code that runs fast. So we do not have Sister in Squeak. What we have now is just the Smalltalk part of the bytecode set, right? And what we're talking about when we're saying let's apply Sister to one's code is something quite different than just compiling to use the Sister bytecode set. And I don't know why people are confusing that from time to time. I'm not frustrated.
Well, I'm not sure if all the time we confuse those things, but maybe we are trying to speak in a kind of shorthand way. I mean, to use Sister for this code would mean either using your optimized recompilers or using a separate set of methods that use the new bytecode, the unsafe bytecode. I mean, we could simply have an unsafe byte at put, right? Why not have
this? Yes, all of those things are there already, but what we don't have is the instruction set defined and the mapping defined so that a context would include a byte stack that could hold the vector floating point data and a set of primitives that would operate on that alternate stack. So if we're just talking about integers, the problem with the current model is that what you have on the Smalltalk stack are small integers, whereas what you want is unboxed integers on a separate unboxed raw data stack and instructions that operate on that. And I haven't done the context stack mapping machinery to implement that yet. So this is part of the ongoing work.
Well, but in the meantime, we could use native integers and floats in arrays passed by reference, right? Just a pointer.
Yes.
Okay. That's enough to get started. I understand that adding a separate stack for native data types is major work to be done on the VM. Doesn't sound
well, it's not so much that it's major work as that if the community could cohere, then it would be work that could be done quickly, but and that's the key issue. But anyway,
yeah,
that would be that would be the first time in 30 years since I was doing fourth interpreters building something like that. I never thought about the possibility of doing this in a Smalltalk VM.
Yeah, it's been.
I'm certainly not aware of any Smalltalk VM that does it now.
No, but it's we've Clement and I have been talking about it for 10 years now. It was an obvious direction to go in, and we were discussing it in kind of 2011. The makes perfect sense is to extend context with a subclass optimized context that has an additional stack object, which is byte data, and a whole series of instructions which do basically at-put on that byte data, and then in the JIT, those at-puts and specific locations within that byte stack are mapped down onto the FPU registers. So that's always the idea, and then if computation is interrupted, the registers are written back to that state, and the Smalltalk debugger presents it, with the abstract computation model provided by context and the debugger, and that's a two-way bidirectional mapping. So it's a very attractive way of going. The thing that it doesn't scale to is coprocessors, but even that, you can imagine a virtualization scheme for coprocessors depending on what interconnect you have with the coprocessor, right? A remote context object or whatever that you can materialize and things. And that seems to me again a very, very powerful direction to go in, and again using simulation as your way of getting there. This is all a very, very coherent thing, and what we need to do is to cohere the engineering effort so that we can make non-glacial progress. Because these architectural ideas are straightforward and realizable, and we have a really good understanding of it. What we're not doing is as a community trying to figure out how to put effort in. Because the benefits are clear. We could have something. We could have this Quies model pure Smalltalk, right? Having no more than the 380 lines, running as fast as that you could get from the best C compiler. If we could only collect the engineering effort, right? But if we don't collect the engineering effort, we have to do all of this. We in the end we have to do more effort, right? We have to write a compiler to C. We have to translate from the etc. And then we have none of the benefits that come from having the Ouroboros, right? The Smalltalk compiler that can then apply to any Smalltalk code in the image without needing to look at the problem in isolation and consider that mapping, etc.
You are absolutely right in that. Coordinating effort has always been something very difficult to do in our community, and most projects that did some significant advance in any area have been led by one person, as you perfectly are aware of.
Yes, you and I are in the same boat.
Indeed.
Yeah, and it must be. I love your calm. I'm much more volatile, and so I rail and I complain. But you look at the Faro effort, and the fact that they have 1 megabyte Smalltalk VM and 12 megabytes of SVG, etc., DLLs, Cairo DLLs around it, and a solution that is not debuggable, that is fragile, that is big, that is clumsy, and if they'd have collaborated with you, you would have been able to finish. You've been doing this for how long? 4 years? 5 years?
Me?
Yeah.
And this thing? No, yeah. Over 15.
15 years. Right.
Yes, yes. I started this project. I remember perfectly well because in 2003 I was lucky enough to have lunch with Alan Kay and told him that I was thinking about starting this project. And I already had some of the ideas. Others, I went discovering them in my way. But yes, that around that time I started working on this. I forked Squeak from 3.7 and started working on this. Yeah, over 15 years ago. Not easy.
It hurts. It hurts emotionally.
Well, I mean, I started this in a time where when I used to say soon displays will be higher resolution and all the Windows and Mac stuff will break around 2004, maybe. Maybe, Leandro, you remember me talking about that in our lunch at noon. And nobody was paying attention to that. And then Google did Android, and they said they were designing a very new user interface model from scratch and blah, blah, blah. And I said, okay, this guy will target phones. Phones vary a lot in resolution, so they will do it resolution independent. And what they do is to require the programmer to provide art in several different resolutions to pick the closest one to the display. So it's a piece of crap, okay? Yeah. What they did is a shame. And then we had the Mac Retinas and all the stuff. But still, what is a Retina Mac doing with a Squeak or Quiz image? It is scaling the pixels, okay? If you start Squeak or Quiz in a Retina Mac and ask for display extent, you don't get the real resolution of the machine. So Apple is still scaling stuff because they don't have a decent programming model for handling the high resolution displays. They introduced it in the industry over a decade ago. So that's what hurts me. Not spending 15 years on this. Spending 15 years on this and think that the rest of the world is not catching up yet. So we still have our edge over them if we can make this work and be usable for everybody. What can I say? We need to keep working.
Yes. One, if possible, could we meet for 10 minutes immediately after the meeting? Because I think the primitive that you want to access the display bitmap is already in the VM.
Yes, of course. I would be more than happy to do that.
So Juan, I have a question which is more of a technical or from a user perspective, right? So I've been using vector editing tools for a long time, like Inkscape or things like that.
Yes.
Well, one of the nice things on your approach is that you can program your vector editing tool, right? So you can generate a lot of different vectors and generate stuff from there. So have you thought about writing a vector editing tool on Quiz or something like that? Of course, yes.
Yes, and we are not that far, right? I already wrote an SVG parser that builds a structure of morphs for each SVG element. So all you need to do is to use the Morphic tools and Halo and stuff to group together your SVG morphs and just generate the SVG from that. I would not write a different tool. I would just improve the tools in Morphic so they get good enough to do that. Something that I will want to do at some point, for example, is to do a nice tool for handling control points in Bezier curves, that kind of stuff. That Squeak had for its splines many years ago, so it's stuff that is perfectly doable. Yeah.
For making presentations.
For making presentations or just for replacing Inkscape, right?
Yeah.
In Inkscape, you use a closed tool to build SVG.
Yeah, you don't need two different tools, Inkscape and
you don't need them. Yeah. And if you want to build SVG art, just to export as SVG to some morph and it will work. It's easier to generate SVG than to parse it, and I did the parser. So doing the generator is like a print on each morph. It's pretty easy to do.
And what is the cost in performance compared to a typical rasterizing engine? So how much do you have to raster?
Yeah, I did an interesting experiment many years ago. It was over 10 years ago, maybe 12 years ago, for a previous version of this code, but pretty similar, not too different in the end. And I compared its performance I found online a benchmark between, written by the author of Anti-Grain Geometry. Anti-Grain Geometry was a big thing at some point, and then it was not developed any longer. Comparing Anti-Grain Geometry and Cairo, okay, and showing that Anti-Grain Geometry was much faster and higher resolution. So I built the same benchmark in C, using pure C without a SIMD or anything, and run it and compare it with them. And my code was faster than Cairo, but slower than Anti-Grain Geometry. But it was more general and better quality, so it was okay. Yeah, my engine is quite faster than Cairo. It's simpler too. Cairo is very complicated. It's running it's doing a lot of complicated and expensive operations on the vectors or themselves before rasterizing them, because of the approach they took to do pixel coverage. The approach is simpler and it's actually faster.
And how do you compare it? I would say algorithmically, or in the way that the graphics processing pipeline usually works. Like you, for example, just set up a pair of points and then say, okay, now we have a rectangle. Now we have a window where we have to prepare our camera or viewpoint or things like that. So how does this compare to that?
There are no camera or viewpoints because this is not 3D. Okay, that is for 3D frameworks. In 2D frameworks, you usually don't.
Then comes another question, which is, can it work on 3D? But okay, answer first the other one.
Yeah, it's not a 3D API. What I am doing is to simulating a pen that moves on a piece of paper. And that's what I am doing, and it's pretty simple actually. If you look at how it works, you will think I'm cheating, but it works.
It's some kind related to ray tracing or something like that?
No, ray tracing is also for 3D. This is not 3D, this is 2D. It's plain. There is no lighting, there is nothing of that.
Javier, what you should do to have a look at the 3D stuff is talk to Ronnie Salgado. You know, we're in Turf, Ron, Teitelbaum, myself, and Ronnie are working together on Turf, which is fully 3D, and we're using his engine. His engine is a 3D model with all of the power of OpenGL, and it is expressed as a set of primitives that run on a given GPU. So we have backends for Metal, for Vulkan, for Direct 3D, and OpenGL. We don't use the OpenGL backend. And this framework is driven centrally by in Smalltalk to C++ compiler that generates the code that is then compiled into a DLL or a dilib that runs on the coprocessor and has a full 3D model. And so Ron is here today. I think we're very, very interested in merging Juan's and Ronnie's model, because we also have the overlay of Morphic on top of the 3D. So we have Morphic widgets at the side of the 3D space to interact, do text chat and all of that, and to use a beautiful scalable Morphic is a much more attractive approach than.
Yeah, I took a quick look some months ago after Elliot, you told me, at Ronnie's work, and I didn't find it to be an obvious backend for my work. Okay,
I don't think it is. I think
I agree. That's just a clarification. Although the possible interaction between both systems is therefore a bit more complex to analyze, but we should do it. I mean, we should integrate them in some way that makes sense. I still don't know what that would be, but yeah, it would be cool to do it.
Yeah, I volunteer right now that perhaps in a month or 2 months we do a talk on the current state of TURF, but we wouldn't do it in Zoom. We would do it in TURF.
Oh, that would be extremely cool.
I think
very nice.
Hi, this is Thorsten. I have a question too. I remember back in Squeak when there was Andreas implementing if you hit a morph, so he did a trick by not calculating the hit point, but if I remember correctly, it was he just painted it on a form in black and white, and then just checked if the pixel was black or white, so you could quickly find out if you have hit the morph or not. And in the initial start of the presentation, you said, okay, this is handled by the framework at the moment to find out if you hit the morph or not. How is this done in this vector kind of thing? Because you do not have the bitmap or form that you could find out the pixel.
Well, I had an idea, and also memory is much cheaper today. Okay, so if you have a high resolution screen with full color depths and all the stuff, maybe we are using something like 8 megabytes of RAM for the pixels, right? And we're using usually 32 bits per pixel. We use 8 for red, 8 for green, 8 for blue, and 8 we don't use them, we waste them, we don't use them at all, okay? So what I did is to set up a separate display object, okay, the same size, 8 megabytes with 32 bits per pixel. And what I did is to use 8 bits for flags. I think it's useful to have some auxiliary flags for the engine to use. And the rest of the 32 bits are used for holding a morph ID. So each pixel actually knows which morph it was last drawn there. Okay, so all I need to do is to query the pixel and see if the ID matches the morph ID. That's why morph has an ID instance variable in Quiz.
Oh, that's great. That's really cool.
It's extremely fast. It cannot be done faster than that. It's just a query on a memory access.
Cool, thank you.
It's one of the advantages of writing the graphics engine myself, right? If I had used Cairo, for example, I would have to work a bit harder to prepare a separate surface and to hack the color management in Cairo to use it for morph IDs and being sure that it doesn't do anti-aliasing because this cannot be blended, obviously. But just writing the code myself, remember when I showed you the method, the code that did byte at put? Well, the next line did the same on the morph IDs instance variable. that is parallel to the form. And it works quite well. And that's also the reason why in Morphic 3 you don't need to answer the display rectangle for a morph. The engine can compute it itself when it draws the morph and caches it in a private instance variable you never need to care about.
I think you may have lost one again.
Oh, did he freeze?
Did he? Oh man.
Start stepping again, Juan.
Well, I have to get back to work, so I'm gonna say goodbye to everyone. Bye, everyone. Wait, I'll turn my camera on.
Heart and radiant contentment.
Hello.
Cheers, Ron. Talk to you soon.
Yeah.
Hi, everyone.
Thank you everybody for participating. If you go to FAST.
I'm sorry to interrupt. I was talking with Juan. He's going to connect using the phone to say goodbye. So let's wait for him a little bit.
Okay. Meanwhile, I'm doing here the the address of the site in fast.org.r so that you get news, and there you have a form for submitting talks if you want to give a talk. So you are very welcome to send something so that we can schedule it. I think, I'm not sure, Guillermo, are you there? I think next time it was going to be yours, but I'm not sure. Maybe he's not here.
Next time is Guillermo, yes.
Guillermo. Okay, so we have to set the date.
Juan is back.
And what was it about?
It's about a surprise.
Okay.
That's good. We like surprises.
That's what I wanted to hear.
Sorry to interrupt for a second, folks. Here I'm back. I'm on my phone. I believe that updating my Mac to the new Big Sur operating system may be the root of this problem because it used to work very smoothly. Sorry. Yeah, please go on. I'm on my phone now.
So, Juan, if I want to get in touch with you, I can. How can I get in touch with you in the next few minutes?
In the chat, I wrote my Skype ID and also my email and my Twitter. If Skype is okay with you, we can talk over Skype, and otherwise you can contact me via DM in Twitter or an email, and we can coordinate wherever you prefer.
Guys,
both on Discord, no?
Sorry, I have a request. For those of us who can afford $5 or $10 a year, I mean, we need very little money, but we have some. We need some. We have some, and we need some. So if you can donate $5, $10, that would be very good for us because there are some admin costs, the bank, etc. involved. So just that. If I don't want to bother anyone, but just consider it.
Sure.
Okay, if there is nothing else, I hope to see you in a few days. We will let you know of the next talk. And be safe and keep in touch.
Okay. Thank
Bye-bye,
you.
everyone.
Bye-bye.
Thank you, everyone.
Great
Thank
talk.
you very
Thank
much,
you.
everyone. I hope
Bye-bye.
Nice job, one.
Bye.
Thank you again.
Bye-bye.
By the way, Elliot, I don't know if you were here earlier to see Queese on
Yeah, I saw it. It's beautiful. It's super cool. I saw you doing it, and
it works. It works. Amazing. Thank you again for the VM work. All these
No,
years.
you're welcome. Thank you for all of your work for the VM too. So
Oh, not much there. Drop in the bucket, but the sea is the ocean. Whole ocean is made of drops. So
yes,
they
exactly.
all let up.
Exactly. Yeah.
Take care. Thank you.
So can anybody tell me the time at which one posted his Skype ID? I'm trying to find it. I don't know whether there's any search in this thing.